to a BixeLab discussion on biometric artifacts. So today, my name is Ted Dunstone. I'm the Senior Responsible Officer at BixeLab, and I have with me Stewart, who is the Laboratory Manager. And we often get asked questions about the sorts of artifacts that we use as part of the presentation attack testing. And I thought it would be useful to have an interesting, basically to go through some of those presentation attack artifacts, talk a little bit about the creation and about how they're used. And we will step through a few of the different modalities as well. So Stewart, should we start with face? As I said, perhaps talk a little bit about where the artifact has come from and how we use that artifact.
Yeah, absolutely. So face artifacts, like any artifact, ranges from sort of a level 1 through to level 3, defined by the ISO 3107 standard. And we start at level 1 artifacts, which are very simple artifacts, generally sort of 2D type things, something you can produce at home quite simply, through to level 3 type artifacts as well, which includes much more sophisticated and potentially expensive type artifacts. So at this sort of level, at level 1, we look at quite simplistic type artifacts, including some things like photographs, as well as like paper type masks. And there can be subtle differences around these different types of artifacts that can, depending on the type of system, can change the way that it can perform against these types of attacks. So this is just a simple 2D printed mask. In this particular one, we have a cutout mouth. We also have cutout eye holes. This can depend on how the system's going to perform against this. Where something might be looking at the eyes, simply cutting eye holes and having a real head behind it can be enough to defeat a liveness detection system. It can also be differences such as the type of paper that is used and the way that reflects back towards the camera.
And it's worth remembering, of course, with any of these artifacts that it's what the sensor sees, or what the sensor is able to see, that determines whether it's going to be able to be a successful spoof. So in this case, if you have a camera sensor that is just taking a photograph, it doesn't contain information about depth. So it's much less likely to be able to pick up where you've got a 2D artifact.
Yeah, absolutely. So moving on from that, there's some other artifacts that we might look maybe at a more level 2 type artifact. And that is things like this, like a half face type mask. So this particular one is printed on fabric. There's an element of a 3D element to this one. So this has so you can see the nose over that one, as well as getting some contours around the face as well. Yeah. And these ones can be based on real identity. So this one is of myself. This particular case.
And where did you get that from? So ordered from the web?
So these are ordered online. These ones retail about $50 each, and they're printed there from a photography company that produces these based on photographs that you provide to them. Obviously, very topical, being a mask in times of COVID. So moving up from level 2, we move into sort of level 3 type artifacts where you start getting a bit more sophisticated and a lot more processes involved in creation, and the cost goes up as well. So the first one I'm going to show is a 3D printed head. This one here. So this is done from a scan from an iPhone device. And it's a scan of my head moving around with a pretty reasonable detail, and then that's then been 3D printed on a resin printer. And the advantage of this is you end up with a 3D model that you can also use you can use it to create other 3D heads like this. They can be bigger, smaller. They can be printed in different colors, and they can also be quite easily turned into video-based artifacts as well.
Do you want to talk about the relationship between those and quality? So, for instance, obviously that doesn't have any colouring to it.
Yes.
But in a quality sense, you potentially could still use it, right?
Yeah, absolutely. So as Ted has pointed out, this one doesn't necessarily have any colour. However, that's like we spoke about before. That's not necessarily important for all types of biometric, presentation attack detection, particularly where this contains relevant 3D data to provide a match, it may not be necessary to reproduce any kind of color or textures. So moving on from that, I have another level 3 artifact with me. So this is a silicon mask that we've procured. This one has facial hair as well as eyebrows, and as you can see, has a lot of realism to it. These types of masks, this particular one, can retail around $1,500 to $2,000 US. And these can be very effective in spoofing presentation attack detection. These days, some are increasingly good at detecting these types of artifacts. However, we do find this is going to spoof most types of systems even today.
All right, thanks, Stewart.
And just to add one more thing to that too, this one is just based on a generic model. If you were to attempt to produce one of these of a real one based on photographs, such as myself or of Ted, these types of artifacts can go up significantly in price. These can something based on a custom sort of 3D model or based on photographs only can retail from like $10,000 US and up essentially.
Yeah. We think there are a whole range of different artifacts that are coming on with new materials, which make it easier to do this sort of spoofing. Also, of course, we're dealing with physical spoofing at the moment, but there are all sorts of challenges with deepfake and machine learning type fakes as well. Okay, Stewart, what modality should we look at next?
So I have a couple of examples from some iris testing that we've performed. And iris systems are quite unique in that they work on a near-infrared wavelength, and a lot of the spoofing techniques for an iris system are based on the means to produce artifacts that can produce something that looks real, like an iris, in the near-infrared spectrum, essentially. So one example I have here, this is a colored contact lens. So this type of artifact are quite easy to procure and quite cheap. And really, this type of artifact is very much focused on an identity transference type attack. So this is the type of thing that I could wear for an enrollment process, and that then becomes an artifact that can be provided to someone else. That they can then verify as me using this very small artifact and in a very sort of covert type way as well.
Can you perhaps elaborate on the sort of difference between enrollment transfer and direct attack?
Yeah, of course. So when we talk about enrollment transfer, that's the type of attack where we do have something like this, where we have an artifact or some type of attack where we're producing an enrollment within a biometric system that's an existing identity within a system that then becomes spoofable using that artifact from another person. And that can be of particular interest in some attack scenarios. That contrasts to other types of attacks, particularly based on face, like we just spoke about, where we look at where I'm trying to spoof a particular identity. So I have this face of myself, that someone might have produced from a photograph that they've taken of me. Perhaps they've taken that photo or taken it off social media or one of the many other sources online. Still on the topic of iris, another artifact I have with me is I have some ocular prosthetics or a glass eye essentially that you might be familiar with, and even up close these have very high levels of realism, and these are very effective in spoofing an iris system and are quite small and again produce something that can easily be transferred from one person to another with this simple artifact. And even in the near infrared spectrum, these still look very real and very much like real eyes, essentially.
There's also an important aspect to any of the sort of testing, because obviously these tests exist within a particular context, right? And so not all artifacts are going to be able to be used in all contexts, because whether they're attended or unattended makes a difference in terms of how an attacker is going to be able to present themselves.
Yes, absolutely.
All right, shall we move on to fingerprint?
Yes, of course. We have a lot of different items for fingerprint testing within the laboratory, and creating fake fingerprints can be both simple quite difficult depending on what you're using. And really it's about, there's two key things that we're talking about here. One is what the mold is made from, capturing that level of detail from the fingerprint, and then what substrate is used to produce the finger itself. So some of these particular ones I have in front of me, these are plaster finger molds, and then the substrate used is a silicon type material to capture that detail. Both of these those two elements will determine the level of detail that's captured in the fingerprint, but also depending on the type of sensor that's used on the fingerprint as the fingerprint sensor, you'll get different behavior depending on the substrate. So things like the conductivity of a finger is not always reproducible with all the same types of materials, for example.
And can you talk about the difference between covert or cooperative and uncooperative in fingerprints particularly?
Yeah, so there is, so again, sort of talking about a similar type of concept there, we have these can be fingerprints that you can lift a latent print of someone that you know and you're interested, someone may be interested in spoofing, and they can use that latent print to produce an artifact such as these to spoof a system. But it could also be creating a fingerprint that can then be, much like before, that can be transferred between different identities as well.
Yeah.
To perform that, and that becomes a cooperative type attack.
And lastly for today, a little bit about speaker verification and creating artifacts to test with that.
Yeah, so with voice verification, there's a lot of different techniques that you can use, but really they fall into one general category, and that is around creating recordings essentially that can be used to spoof. So those could be recordings that I have. They could be straight playback type recordings of someone saying, whatever the relevant phrase is within a particular system. It could also be taking that speech and building a model that can replicate different elements of speech. And those types of attacks have been reported and have been successful, within real contexts. And then in applying that type of attack, it does depend on the type of system. So we look at voice biometric systems that are used through phone channels, but then we also look at ones that are used through digital channels, and those present different characteristics. So where you're using a phone channel, the quality is significantly reduced from what you get on a digital channel. And that can, in our experience, makes it much easier to spoof using playback or recording style attacks. And playing those, a lot of the means in spoofing those types of systems is around playing that back in a way that's going to spoof the system. So it could be direct injection into the phone, or it could be simply playing a recording into a handset, etc. And that's where things like we have this sound meter, and the levels of background noise around that can change the way something behaves against a presentation attack. So we find something where there's a playback attack that may be tested a number of times and perhaps not be successful. If we introduce higher levels of background noise around that can sort of mask the fact that it's a presentation attack.
Thanks, Stewart. We hope we found this interesting. If you are interested in some more information or finding out more about the testing process, please send us an email at info@BixeLab.com or reach out through LinkedIn. Thank you very much.